Alright, Jordan, I'll let you look at the sheet that you have printed out and everything, but we have example 9.5. This has to do with velocity in this when there's motion in the same direction. So, for example, in a high-speed chase, a police car is behind a stolen vehicle about 150 feet. They are traveling north on a highway, and the stolen vehicle is traveling at 87 miles an hour. The police officer is traveling at a speed of 92 miles per hour. What is their relative velocity in miles per hour? We're going to do the other part afterwards, but what is their relative velocity in feet per second? And more importantly, why would this information be helpful? So let's go ahead and tackle that first part. So the first thing I always like to do in these relative velocity problems is I like to draw a picture. So just a little simple picture. So we've got I like to use boxes. Obviously they're not to scale. We have them going in the same direction, and they're going north, so that's why I have them pointing up. So I've got the stolen vehicle, which is 87 miles an hour. And I've got the cop car, or the police officer that is behind him, chasing him, going 92 miles an hour. Well, as you can, if you remember from our little cheat sheet that I had everyone do, when they're going in the same direction, north, south, east, or west, same direction, we're going to subtract. So, and then we're going to use some common sense. A lot of these story problems or word problems, we always need to make sure that we're trying to make sense of what they're trying to ask. So, since it's, don't want to necessarily deal with negative numbers for now, but we will probably end up doing that at some point in time. We got 92 miles per hour minus 87, since we need to subtract the two numbers. We're going to get 5 miles per hour. Now, here's the tricky kind of part. So we've got a speed of 5 miles an hour. And it's actually a relative velocity as well, but we don't have a direction. Okay? So we have 5 miles an hour, and that's either them getting further apart from each other or getting closer to each other. Okay, if they're going in the same direction, they're either getting further apart from each other or they're getting closer to each other. Now, based on the information, we've got a police officer in a car behind a stolen vehicle person in a car. Which one's going faster? Well, the police officer is going faster. So they're actually getting closer together. So this is going to be 5 miles per hour. Closer together. Traveling north. Okay. If it was the other way around and the stolen vehicle was going faster, then they would be getting further apart traveling north for this. The next question, we're not going to actually do the conversion. I just want you to understand why this information would be helpful in this situation. Excuse me. So we have, what is their relative velocity in feet per second, and why would this information be helpful? Well, if you notice up here, the information we didn't use was 150 feet. If they're 150 feet apart, and we have the information in feet per second, we could actually figure out when the cop car or the police officer is going to catch up to the stolen vehicle. Let's say, for example, it was 10 feet per second, or we'll just do 10 feet per second. If it was 10 feet per second, then it would take 15 seconds for the police officer to catch up to the stolen vehicle. So that's the main point that I wanted you to get out of this second portion of the question. So I hope you're feeling better, and we will see you on Wednesday.